So we'll go first of all to look at the agenda for the session. So I'll give you a very brief introduction to Visual Solutions and who we are, and then we'll discuss the challenge of how can you really design complex systems with requirements statements alone, and that's really the challenge we're trying to address as part of this webinar. And this is talking about really managing the so-called world of text and grammar versus the world of models and pictures. So, and we'll talk about the benefits of why we should employ both of these techniques within an integrated project team. And then we'll go through some of the benefits of tool support to maintain traceability between these so-called two worlds, the world of text versus the world of pictures. Then we'll give you a demonstration of the visual requirements integration with Spark CA before we then wrap up with some conclusions. Okay, so that's what we're going to cover today. So moving on to the next one. So who are Visual? So Visual is the company absolutely specializing in the subject of requirements engineering for system engineering and complex IT systems. And we're also finding now increased interest actually in the arena of project management. So, so we are expanding a little bit the scope. Visual was actually founded in 2007, so we've been around for a few years now, nearly 8 years, to focus entirely on the delivery of innovative requirements solutions, requirements tools. We are the manufacturer and distributor of visual requirements, a leading, recognized now as a leading requirement solution. We have our US headquarters in San Francisco, and we have a headquarters also in Madrid in Spain, with offices now in the UK, Sweden and Germany. We are ISO SPICE certified, and that's primarily because we do a lot of business in the automotive industry within Germany, and part of that ability to work in that area is we have to be ISO SPICE certified. And then finally, independent from requirements tools, we're also certified or authorized by the International Requirements Engineering Board to deliver certified training for requirements engineering. So that's a 3-day training course, foundation level, where you come out and you can actually do an exam to get certification in requirements engineering. There are 3 levels of course that are supported now. There's the foundation course, the advanced course, and the expert course, which is nearing completion now. But certainly the foundation and advanced courses are already available. So that's all I'm going to say about Visual, but obviously we'll focus on requirements management. So what is the requirements challenge? Well, the requirements challenges I see is in several forms. The challenge is to understand your customers, your stakeholder expectations through a collection of grammatical statements alone. So that's the challenge. Can we really do that? Is text and grammar good enough? That is the question I pose really during this webinar. The problem we often find, though, with words alone is that they can be open to interpretation. I will be kind and say it could be reinterpretation, or in some instances it could even be misinterpretation. So how do we actually gain clarity to ensure that we don't reinterpret the requirements that are placed upon us by whoever those stakeholders may be? The issue we have with text alone is because we are only human, is describing a sequence of events through words alone can introduce human error and also incompleteness. So this is where we think about how can we actually fill in the gaps, how can we derive the lower level requirements that may be may be missed through just describing them through words alone. And this is where we start to think about the idea of modeling. This is the viewing those same requirements but in pictorial form. So use of modeling techniques to elaborate and clarify your stakeholder and client needs, and particularly useful if you're doing a complex sequence of interactions between subsystems, and we'll talk a little bit more about that later on. Trying to visualize that and turn it into text. Some people are very good at it and some people are not so good at it. As soon as you start to present that in some sort of drawing, in some sort of UML type format, then we can start to gain clarity about that interaction and ensure that we don't inadvertently miss any of those interactions out. Having then created that in the model, then you can use the model to help you feed that back and derive those lower level requirements that in text alone you may have overlooked. But in doing this, if we're introducing this concept of working in the world of words and working in the world of pictures, what is absolutely critical then is to start to maintain traceability. Maintain the traceability from the stakeholder expectations, typically the world of text, to the system solution throughout the design lifecycle, providing real-time links between the world of words and the world of pictures, maintaining that we maintain sort of synchronization, if you like, between those two worlds. But also, why do we have to bother with words at all? Well, the reality is the world of words is still critical for the description of our contracted project deliverables. The bottom line is that lawyers and contracts people still prefer things to be described in words rather than purely just pictures. And so this is why we, although one or two of us would like to get rid of the world of words altogether, the preference is that we still have to describe our systems in the form of words, and they can of course be supported by pictures for clarification, but words is still the basis on which legal contracts are drawn. And finally, at the end of the day, we still have to produce project deliverables in terms of documentation. So projects still need to produce fully formatted documents and metrics reports to track the progress and document the project deliverables. So that's really not going to go away, certainly from my experience. So that's the requirements challenge. Let's go and look at now what are the benefits of modeling requirements. Well, the first news about modeling is it is very well recognized as a vehicle for elaborating and forming new requirements. There are many modeling standards to support system definition and development, mainly motivated through the OMG, and that's obviously supporting things like UML. And here you've got SysML, you've got MODAF, which is the MOD architecture framework, and you've got DOD, which is the Department of Defense architecture framework. The unification of these two architecture frameworks became known as UPDM. And in the commercial world, you've got TOGAF for supporting architectural frameworks in the commercial sector. So all of these standards, however, recognize the benefits of the through-life systems approach to requirement solicitation. And simulation-based acquisition advocates the use of a central cohesive model for developing the system objectives from which requirements can and are derived. So, and this is no surprise, I'm assuming, to many of you listening here today. So analyzing your customer requirements, well, historically and still typically, requirements still often start in the world of words. The stakeholder requirements, and the stakeholders can be from many sources. They can be obviously your accountants making sure your project doesn't overspend, your customers obviously is your primary stakeholder still, and your marketing department. They may have a view of where they want the business to go. And these will come in form of system specifications or develop down into system specifications, which in turn can end up being spawn out a myriad of derived subsystem specifications. And we have to also, in that process, be compliant with regulations and standards, and through that produce the system. However, we still somehow need to, what I term, bridge the gap. And bridging the gap is ensuring that the as specified system, the document there on the left-hand side, maintained and is aligned in real time with the as delivered system, the thing on the right-hand side. And obviously that could be any system. That could be a physical system or it could be services. And so we've got to bridge this gap. So here's my Golden Gate Bridge, where we bridge the gap between the two things. And so as systems become ever more complex, it is becoming increasingly difficult to bridge the gap between the stakeholder expectations and what can be delivered within the constraints of cost, timescale, technical feasibility, and risk. And what is also important here is that we ended up with a documented account of the as-delivered system, not the as-specified system. And that's really important because obviously the specification starts in one place, but life has it that the specification you start with does not very often and very rarely, in fact, represent the system that ultimately gets delivered, because change happens. Change happens through that life cycle from system specification to system delivery. And it is important that the system specification is not a fixed document that stays fixed at the beginning and throughout the program. It's a living document that evolves during the project, and we need to reflect, the documentation needs to reflect the as-delivered system, including all the changes right at the end of the project. So sources of system requirements, well, this will come as not too much of a surprise to many of you. So system requirements are the core of where we start. They then need to reflect the requirements change that occurs during the program, and then we have synthesis of those requirements during the program. And the sources come from many places. So you've got your user requirements, and of course that's in part your stakeholders, your operational objectives you're trying to achieve from the system, the standards and regulation and any regulatory constraints that may be placed on your requirements. Even strawman architectures, where architecture you may be integrating with something that already exists, as therefore you've already got some idea of an outline architecture. Then there's the really difficult bit, the ILS, what I call the ilities, the maintainability, the reliability, those really the non-functional requirements. Now this is one place, by the way, where the world of words really does come into its own, because the world of pictures and models are very much stronger when trying to describe the functional part of your system description. They're not so strong when you need to define the ilities, the things that unfortunately can very often bite you in the latter stages of the system development. And that, with the ilities, you get the maintenance philosophy. The maintenance philosophy is also very important here, because we then characterize how modular does the system need to be for reasons of maintainability. You know, if there's a critical part of the system that, should it fail, we need to replace very quickly, then that defines the system design and how modular we make that system. And that can obviously affect our system requirements. And then finally, the other big factor that's coming into play nowadays is the use of off-the-shelf component specifications, the use of off-the-shelf equipment. And there, in that instance, what becomes vitally important then is the interface, the boundary conditions of the off-the-shelf equipment, and how you're going to interact with it with the wider part of your system description. So here we go through this, what I term this requirements elaboration process. So on the left-hand side, we've got this world of text. The statement of need typically starts in some sort of textual form, and then it grows to to the bottom of that pyramid of requirements, leading to your requirement specification. And in the ideal world, it should also lead in parallel with your validation specification to prove how you're going to verify and validate those requirements. The other benefit, by the way, of actually trying to do these two things in parallel is that you get two shots at making sure that your requirements are not open to interpretation, reinterpretation, or misinterpretation, because you're defining the requirement and you're also defining how you intend to verify and validate that requirement. But during this process of elaboration, the world of pictures, the so-called world of models here, can really help to fill in the gaps, to help you derive those lower level requirements, to take away some of the human error, if you like, and visualize some of those interactions between the systems, particularly if it is a modular system or you're using off-the-shelf equipment. We need to understand how the information ping-pongs between the subsystems. And in describing that in a picture can help you visualize things and derive those lower-level requirements, which in the world of text alone can all too easily be missed. And out of the model, you should come out with some view of your system solution. So an example here is deriving the requirements via models. So here we've got two subsystems. Your subsystem B could be that commercial off-the-shelf bit of equipment, or it could be that existing system with which you have to interoperate. And subsystem A could be the system you're developing. But obviously at the moment we have a gap between those two systems. And the reality is that we need to translate some information between those two subsystems. And this is where modeling comes in as a very powerful vehicle for understanding that exchange of information, that handshaking of data between these two systems. And out of that handshaking, we can start to derive those lower level requirements using your system model, and then linking those back up into original system specification, ensuring that you end up with a complete and documented account of how those two subsystems are now going to interwork with each other. And that's the power of modeling. And of course, what is important here is that we maintain real-time synchronization between my world of words on the left-hand side and the output from my model on the right-hand side. So, but it's important here that we play to the strength of your whole project team. Now, the reality is that some people are really good at communicating via words and grammatical statements. And that is their forte. They love words. But the brutal reality is some people actually are not so good at words. They would prefer, they're much better in the visual world. They're very much better in describing the system through a picture, through a model, and it gives them clarity. So, and by the way, you know, you have got engineers, you have got business analysts. Some are better at words than pictures, and some are better at pictures than words. It doesn't make either set of those people any worse as engineers. It doesn't make them any less able to make a significant contribution to the project team. What is really important, though, is that you talk to those two strengths of those two groups equally. So integrated project teams should play to the communication strengths of all the participants, not just the ones that are good at words and not just the ones that are good at pictures, but equally that their contribution should be equal within within the scheme of the project, and also to capitalize on the creativity that they bring to the table, either through words or through pictures. So we need to empower everyone to contribute towards the system objectives given their particular strengths. So let's use a simple example. And this example, I know it's a very, very simple example, so you'll have to excuse me on this, but to me, it covers it very nicely from my own experience. And I apologize, first of all, it is a UK map. But here's a good example. So someone says, I want to get from A to B, from one place in the UK, in this case, to another place in the UK. Obviously, in your context, it's one place in the US, another place in the US, or wherever you're listening from. Now, me personally, I prefer to see a map. It gives me an immediate visual impression of where point A is and where point B is, and the various roads I have to go through to get from point A to point B. However, there are other people that prefer the absolute concise clarity that language can bring. So here we've got each step of this journey described in precise text, and there are people that absolutely prefer the information on the left-hand side. But in an integrated project team, as I said, we need to cover the strengths and the preferences of everyone working in the project. So here I've got an example Well, on the left-hand side, we've got the world of text. On the right-hand side, we've got the world of pictures. And we've created these, what I term little cobwebs, little explicit links between every stage. And by doing this, we've captured the strengths and the interests of both parties, those that prefer text and those that prefer the pictorial representation. And so we need to capture those two things. So the generic system model describing system engineering is a comprehensive and iterative solving process that is used to transform validated stakeholder needs and customer needs and requirements into a balanced solution set of process designs and system components. So you've got the input and the output and some processing that goes on in the middle. And don't forget, again, your functional analysis is very nicely covered by your system models. Your non-functional analysis is actually in reality better covered through the world of text. So we use the system model, if you like, as a validity gate between all those inputs that come in from the top that we described earlier. And here we're using Enterprise Architect as that validity gate to check for harmony between requirements, but also to look for conflict in requirements and omission. And the models are very good at capturing any omission on that old adage that, you know, a picture spell that says 1,000 words. And we also try and tease out duplication through this process as well. But throughout the process, we need to, you notice at the beginning, the left-hand side, we start with our statement of needs, very often in text. And through the various stages of the process, we can model and derive and solicit additional requirements to ensure that we end up with a complete view of the requirements, not just some of the requirements, until at the right-hand side, we end up with a full view of the as-delivered system, the as-built system, not the as-specified system. So with visual requirements, we now take that information one step further, so we end up with a process view of how the documents and the information in the project is captured, how the information is linked together within the visual requirements database, and we take those out as documents, and we can actually start to, and also on the other side, we take the information out as validation, the verification information from the requirements linked up, and we start to trace this information down into our modeling domain, in this case Enterprise Architect. And notice the example, it's a great example on the picture of Enterprise Architect there, where you've got different parts of the system and we've got interactions between those different parts of the system. Well, this is a very nice visual representation of the handshaking and the interaction that occurs between these different parts of the system. And this is information that we can feed backwards when we go back up the tree again. So we obviously need to maintain synchronization between the requirements and those interactions. But as we go back up the tree, we need to start to take that additional information, those derived requirements from the model, and repopulate the requirement specification. So we end up with a complete textual view of the information which has been derived out of the models and right back up into that part of the requirements lifecycle. And again, we need to maintain that synchronization, ideally in real time between these two worlds, the world of words and the world of pictures. And in this instance, we obviously try, and our preference is we use the best of class tools. Enterprise Architect is one example, but there are many UML and modeling tools that we can bring into play in terms of this type of integration. And we need to establish this traceability to the functional and the physical design elements throughout the design lifecycle. And once you've captured that information, you need to represent this traceability between the requirements and your functional design elements, which may have been drawn from your model. So we end up with this end-to-end traceability in visual requirements, allowing the controlling of complete specification and change, the impact of change at any stage during the project, identifying any missed customer requests, any missed requirements, any missed interaction that could have been overlooked in the world of text alone, which obviously affects your software requirements and use cases, and any unfulfilled requirements. So these elements can be derived from the models developed in Enterprise Architect to fulfill the gaps, fulfill the elements that may be missed in the world of words alone. So with that, that's really the presentation on the background. So I'm now going to hand over to Miguel, who will provide a demonstration of how we marry together this so-called world of words with the world of pictures in real time and show the interaction between those two environments. So over to you, Miguel.
Thanks a lot, Paul. It was a very informative presentation. So I will do as you say, and I will demonstrate our visual requirements and enterprise architect integration to support what you stated, just to see how we can represent both, let's say, worlds, the world of pictures and the world of text. And so, well, we all know that most requirements management tools allow to add attachments or embed pictures into the requirements, maybe diagrams or other kind of files, such as the diagram right here in the description, if I want to. So this way we can have both requirements textual information along with design diagrams so that we can later generate specifications with text and diagrams all together. But well, this obviously has some inconveniences or limitations. The first, our diagrams will become obsolete if we keep modifying them in the modeling tool. The second, we will not be able to collect descriptions, attributes, or other related information of the models in the requirements tool. And third, but no less important, we will not be able to trace or relate individual elements of the model with requirements, but just entire diagrams. Well, additionally, some requirements management tools also support basic built-in capabilities for requirements analysis, such as use cases diagrams or business process modeling. Okay, but well, in most of the cases that will be simply not enough. Why don't we use specialized tools which are the best for the job? In this case, Enterprise Architect for modeling and these requirements for representing the requirement text, and keep them synchronized using our integration. So this integration is based on our SDK plugins architecture. Creating and using plugins for these requirements is no different than plugins written in Java for Eclipse. Just copy the plugin file for the EA integration into the visual requirements installation path under the plugins folder, and the buttons for synchronizing requirements will appear. Okay, so as you can see, this integration is quite simple, but you will see later that it is flexible at the same time. So we are capable of exporting requirements to Enterprise Architect and also import requirements from EA into these requirements as well, and keep them synchronized. It also includes custom attributes and traceability. So let's export a couple of requirements. I will select a previous configuration so that we don't need to go through the configuration steps over and over. And so it is now connecting to the model, no matter if it's stored in the file system or database. And so it is retrieving all the information required from it, such as the hierarchy of packages, the attributes, and other relevant information to display the synchronization configuration dialog. So let's wait until it is completed. Okay. So through this integration, we can export all requirements or only the visible ones. This is fulfilling the current filter criteria. You may also be interested in exporting only those requirements belonging to a specific type, such as functional in this case. So in fact, let's take a look to the data model. Let me go to the second instance of the same project. This is our data model or block diagram. This is a simple example for IT projects. based on the high-level customer requests or user requirements, rewrite or detail system specification consisting of functional requirements, but also non-functional requirements involving performance constraints, scalability requirements, etc. So we will just export functional requirements, just as an example, to write the corresponding use cases in Enterprise Architect to implement them. So another step is to select the package where the requirements will be exported. Take into account that this export process can be used not just for a first import, but also for updating requirements in Enterprise Architect as we publish new versions of the specification. And we can also include the traceability. So we are also able to export custom attributes, and we could even enter a value mapping, a mapping of values for enumerative attributes. Okay, so let's click OK. And while requirements are being exported to Enterprise Architect, we will open the corresponding project and explore its contents. In this example, we are just using one of the examples shipped with Enterprise Architect. But take into account that this integration is independent of the modeling framework you're using, no matter if it's UML, TOGAF, DODAT, etc. Okay, so now if we navigate to the systems engineering package, the requirements model, specifications, we can see the requirements coming from these requirements, along with the hierarchy, the same hierarchy that they had in these requirements, and also the attributes, which are exported to EA as tagged values. Okay, so the traceability is also exported so that I can locate. Okay, good. And also the full RTF description coming from these requirements is exported to EA as the linked document, so that users can also see the full description right in Enterprise Architect if they want to. Okay. At all times, they could also navigate to these requirements to see the correspondent item. Good. So now that we have all this information in Enterprise Architect, we can use them as a basis to create the system architecture, write use cases, etc. So we should be able to include requirements in the diagrams. So let me drag and drop it here, and I should be able to link or trace requirements to use cases, to interfaces, or any element of the design. So once we have the requirements along with the models, even with the traceability, we can generate documentation or any kind of report we may need according to the required formatting, ready to be sent to customers or suppliers. And so this way we have both representations, textually in these requirements and graphically in Enterprise Architect. But we can still benefit of using the tool which is best for the job. So if I go back to these requirements, while the process obviously ended up successfully. So by using the requirements tool for managing the requirements, we can still generate document specifications just as a contractual basis for my customers, suppliers, etc., so that we can then generate Word documents, generate custom reports, etc. We can also import from many sources, from Microsoft Excel, from Microsoft Word, and other systems. We can also use advanced features to analyze the traceability, such as the traceability matrix. like in this case, the matrix with between the customer requests and the requirements, and also with suspect links. So the ones in red are suspect, meaning that one of the items has been changed since we established the relationship. And we can also do some advanced impact analysis using a tool similar to the Microsoft Word track changes, so that I can select several versions of the requirement and compare them, so that I see in red the individual changes, and what is better, I can see just the specific differences in the text in a similar way as Microsoft Word track changes. So as you can see, we can still benefit of all the advanced features for requirements management and analyzing the traceability right in these requirements, while we still are using our dedicated modeling tool. So what we have seen here is just a simple example, I will say. As it is bidirectional and it is configurable, we could have also used it for import requirements from EA into these requirements as requirements derived from the model. Okay, just another use case scenario. So that was basically it. I will hand over back to Paul, and thanks a lot. Paul, it's all yours.
Thank you, Miguel. Thank you for the demonstration. And as I say, it was a simple example, but obviously as your system develops, the more you get more and more interaction between the world of requirements in Visual and the world of models captured here in Enterprise Architect. Just to remind you, while I'm just going through my conclusions, please feel free to raise any questions you may have and put them into question so we can capture those at the end, and hopefully we'll answer any questions that may have come out of the demonstration. So the first thing I'm going to show you is looking at some of the benefits of tool support in this process. And I'm afraid I'm going to have to give you a couple of shocks at the beginning. And the first shock is that contrary to some beliefs, the use of tools does not suddenly increase your IQ. Now, I know this is difficult to take, and I know it's probably a shock, but that is the reality. The introduction of tools doesn't suddenly make you all more intelligent. It'd be good if it did. But and then next one, radical again, I know, but the tools themselves don't, of course, design systems for you. Again, we would like that to happen. Maybe in the future with robotics it could do, but we're not there yet. What they do is they support information traceability. They do take the administration out of creating or maintaining this traceability between the world of words and the world of text, and of course between Word documents themselves. So that's really part of the significant value. They can help in evaluating your design decisions and making sure that you have the information available to you in real time at your fingertips based on the traceability you've established to make informed design decisions rather than base your design on assumptions. And finally, they can be used as a vehicle for eliciting, elaborating, and communicating your understanding of your stakeholder expectations. And that is really important, that this can be done obviously in real time and also show the impact of change before you actually commit to making that change. What is touched if I make that one change to that one requirement? What is touched throughout the world of text and the world of pictures, the world of models? What is impacted? What parts of my system, what parts of my project are impacted if we were to consider now proceeding to make that change? So let's just go through then a few conclusions from today's sessions. So describing systems via grammatical statements alone is open to interpretation. Some would say reinterpretation, some would say misinterpretation, but the reality is the world of text alone offers that opportunity. and obviously we want to tease as much of that interpretation out of the equation as possible. We want to build our systems on concrete, not sand. System models provide a powerful vehicle to validate disparate requirements. And what we're looking for here is harmony between the requirements. We're looking to tease out conflict between the requirements. And most importantly, particularly with the models, is to ensure that we tease out omission, to tease out any requirements that have not been included in the textual description alone. And finally, also to try and get out duplication of requirements where possible. So staring hard at requirement statements alone many times will not always achieve what you can achieve by representing this information in models in a way that you know, around the picture you can have a conversation more easily than you can have a conversation around a page of text. Models can successfully bridge the gap between requirements and design and help you derive those lower level and additional system requirements. And we're looking here for completeness of the system description and to ensure that we don't omit or miss anything out, those nasty things that come and bite you much later in the project life cycle. The world of words is still, however, essential as a basis for contracts and system specification and legal interpretation of your system, particularly if you are working with subcontractors and you outsource bits of your design, or you're trying to integrate an existing system with your new system. And that's really working also with existing commercial off-the-shelf equipment.